Hello everyone, today we are going to talk about moment of a couple. So first we need to define what do we call a couple in statics. So a couple is two parallel forces with the same magnitude but opposite direction. So as long as the forces have the same magnitude but the opposite directions, we could call them a couple. So let's say we have a couple here. Everything is better with examples. Let's say we have 3 Newton here and then 3 Newton here, 30 Newton here. So they have the same magnitude and they are also the opposite direction. Let's call this XY coordinate. If the distance between the two is 2 meters, we want to find the moment of these couples. So the moment of a couple is defined as FD, where the F is the force magnitude of one of the forces, and D is the perpendicular distance between the two. And that's our scalar formulation. So F is the magnitude of one of the forces, so we don't need to add the forces together, it's just using the magnitude of one of the forces. And D is the perpendicular distance between all forces. Between the two forces. So for this example, the magnitude is 30, the perpendicular distance is 60, so the moment of the couple is 60 Newton meter. You are probably thinking this is the same as what we previously talked. What's the difference now? Moment is force times distance. But the difference here is that we are not finding a moment about any point. The moment, we are treating the moment as a free vector. So a couple moment is a free vector that can act at any point on or off the body. And that's the important distinction. So let's make note of that. So the couple moment is a free vector that can act at any point on or off the body. So here for this example, let's say you want to find a moment about point O. I'm just gonna bring write the moment here, draw it here again. I have a force 30 Newton. I have a force 30 Newton here, and the distance between the two is 2 meters. Now I want to find a moment about the center. So summation of moment about point O. Let's assume counterclockwise is positive. So the moment of our first force, 30 Newton, about point O would be counterclockwise, so it would be positive. the moment arm, if the total distance is 2 meters, would be 1 meter. Then the second force, the moment is about 0.0, also gonna be counterclockwise. So it would be plus 31. At the end is 60 Newton meter. So let's find a moment about another point, about point A. Summation of moment about point A. Counterclockwise would be positive as our assumption. About point A, this force is not going to create any moment because there is no moment arm. But our second force, 30 Newton, is creating a moment. And that's counterclockwise. So 30, and the moment arm between where the force is acting and our point A would be 2. So that was 60 Newton meter. So about point A was 60 Newton. You can find a moment about point B. You will get the same answer. You can find a moment about, let's say, a point outside our body, C, and you would get the same answer. And that's the main feature of couple moment that we are talking about today, is that a couple moment is a free vector. It can act at any point on the body and is produced by two forces that have the same magnitude but different direction. And we can talk about the vector formulation of the moment. So in the vector formulation, instead of a 2D definition, we have a 3D definition. So a moment is defined as R cross F. And again, R cross F is not the same as F cross R. So the order is important. But what is the position vector here? So we know R is a position vector, but we need 2 points. So where R is the position vector, from any point on line of action, of one of the forces to any point on the other force. On the line of action of the other force. So we might have more than one couple in our system. And in that case, we use summation of moment. Would be summation of R cross F. So let's say you have a force here and a force over there. Your position vector, your option for position vector could be here, R cross this F. It could be this one, could be any position vector you want from line of action of this force to a line of action on the other force. And at the end, you're going to get the same answer. The cross product will going to take care of our moment. So we have multiple options when it comes to position vector for a couple moment.